Okay, today, so far, I talked about calculation of resultant force at the bottom of a plane, horizontal plane. The easiest form, you saw that at any point on a horizontal plane, pressure is constant. Therefore, the value of one of those pressures should be multiplied by the area of the plane to attain the resultant force. In this example, we also solve the problem from the net force perspective using force free body diagram. Then we solve this example. We said that at the bottom pressure equals to gamma of oil times height of oil, and then we multiplied the pressure at the area of the bottom. In this example also, we find pressure force as a resultant force as the summation of three different forces, one from air pressure, the other from two different liquids, and we add them together to find resultant force. Then we saw that in vertical planes, pressure is not constant, and pressure varies linearly from top to bottom. Going by moving downward, pressure increases. Therefore, we need to find a point which represent the equivalent pressure at entire vertical plane. The point was, after this calculation, we saw that the point was the centroid, and we said that force acting on vertical plane equals to pressure at the centroid times area. The example solved here, and we saw that for vertical rectangular vertical planes or walls, centroid locates in the middle of the height of the wall, and from there pressure at the middle should be calculated, and the result for this question was found. Now we are going to see another plane which is oriented. By this I mean that there is an angle between the vertical planes and our plane or desired plane which is in contact with water. Such oriented planes we usually have in earth-filled dams. You see, we make earth-filled dams with some angle of the embankments, and therefore water is not in contact with vertical shape. To solve this kind of problem, again, the general solution comes from pressure at centroid times area. Again, as this plane is not horizontal, therefore pressure at any point varies. And you remember that pressure is always increases by depth, and therefore we know that pressure at the bottom is not equal to the pressure to here. Here pressure is relative pressure is 0. At the bottom point at the here the pressure is the maximum value. And if I want to show you linear distribution of pressure, here I can show in this way. What is the pressure here? 0. Okay. What is the pressure here? Gamma h, which is maximum. Sorry, pressure is always perpendicular to the point. Therefore, pressure distribution could be linear like this. Here we have gamma h, and at any point, this pressure distribution is that form. As you see, again, it is not uniform distributed. It is linearly increasing distributed pressure from top to the bottom. And to solve the problem, again, I use this formula, pressure at centroid. Now, where is the centroid of this plane? This is a geometric question, not relevant to fluid mechanics. It depends on the shape, and generally shape of these it is rectangular. Again, it is rectangular when you look perpendicular, look from this point to the commonly we show like this one eye, and look from in this direction, you will see nothing than a perpendicular plane. So again, centroid, you remember, for centroid we commonly find centroid at the center of the plane, and this is a case. Now for this part, I zoomed in this part. Okay, I zoomed in this part and showed here. The height of water, this height, equals to 3 meters, and I have the this point shows me this point where the point of the pressure is 0, and this length equals to 4 meters, and I'm interested to find resultant force. Let's show a resultant force here. For example, this is my FR. FR, and I'm looking for this force. FR equals to PC, pressure at centroid, times area. Which area? This area, yeah. And where is the location of centroid? Is the middle. Look, P, pressure at middle. This is my surface. Pressure at middle, it could be here. This point could be middle, and in this point, depth of water equals to 1.5 meter. This is why I divided 3 by 2. Therefore, this is depth of centroid. Gamma H means pressure at centroid. What is the area? Area of this plane, yes. This plane, this length times to the, it should be times to the width, yeah. Maybe for more clarification, I mean such area, you know, this length times to those area which is within the water, yeah, and water acts on it. This length is 20 meters, as you see here. Width is 20 meters, and I should multiply it with this length. This length from if this side is 3, this side is 4, therefore this side should be 5, and my area equals to 5 times 20, and the resultant force will be this value. Okay, here we see an example of a submerged plane which has angle, this theta, also not given, but I see this is oriented, submerged. This is my surface, free surface. The liquid is not water because rho is not 1000, it is 1500 kilogram per cubic meters. And the question asks the 5 meter long, this plane 5 meter long by 1 meter wide. It means that the width of the plane perpendicular to the to your room, to your face, is 1 meter. Slanted gate, it means that in one side we have water. This is called gate. Plate, also gate means a plane. Like this is a gate because it can be open or closed to release these oil. Has a hinge at point O. This is my hinge, and it hinge at here, as shown by the figure below. The fluid on the left side of the gate has a density, also density given. And now what is the force or resultant force acting of this liquid on this gate? Again, I see I have an oriented plane, and I have to use this formula, F equals to PC times area. And PC again is pressure at the centroid. I should find the centroid of this plane, and it is a rectangle, okay? When it is a rectangle, centroid is middle. And where is the middle? Something here. This is therefore my centroid, okay? What is the depth of water above the centroid? Jeren, what is the depth of water above the centroid?
It's 2 meters.
Plus 2 meters plus 8 meters. 8. I have 8 meters here, and 2 meters from here. In total, depth of water. This depth is important to me. This is centroid, the middle. Okay, the middle is centroid. Therefore, depth of water, PC, this is centroid, PC equals to gamma times h. Which h? Depth of water from here to here. And I know that centroid is half of this 4 meters, or half of this value. And here I have 2 meter. And PC can easily find in that way. Rho G, rho is given, gamma equals rho G times h. H equals 8 plus 2 meter times area of the plate. Plate one side is 5 meter, the other side or width is 1 meter, and total force or resultant force could be 734 kilonewton. Yeah, therefore you see that in the case of either vertical or oriented planes, you need to find the location of centroid, then find pressure at the centroid, then multiply by the area of the plane. So easy. Now I'm going to get some conclusion from this lecture, and then we will talk about other kind of planes which could be curved planes, not plane planes. For a plane surface with area of A, the total pressure force can be derived by the following integration formula. And at the beginning, you saw that I said that pressure, I used this formula, okay? I used this formula to find pressure. What does it mean? Actually, assume that this is my, I have such a object in the water, located, oriented in the water, and I would like to find resultant force acting on this area. In general, the general solution is this. Look, because from here to here, from up here to here, you see, pressure is not constant. Therefore, I cannot easily say that if F equals to P times area, because pressure varies. What should I do? What I did in vertical problem, I just select a strip on the wall and then find differential pressure, differential force, and then take integral to find entire force. In fact, the general solution is like this. Look, I have such a shape, irregular. It could not be always a regular shape, irregular, and I want to find what is the resultant force on it. The general solution is this. I assume one very small piece on this shape like this. One side could be considered, for example, dx The other side should be dy. Therefore, differential area, I can find differential area equals to dx times dy. Sorry for such a bad handwriting. Dx times dy. Yes, this is in this differential area. What is the amount of pressure? Pressure, because now I have the depths. For example, let's say this is y. Okay. Therefore, gamma y is my pressure. So at this point, again, at this point, I can find differential force equals to P times differential area. Okay, this is the general solution. Differential force equals to pressure at the point that you considered times differential area. Then what you should do, this is the formula, you see. Then to find the entire force, you should take integral of both sides. Take integral of both sides. Just put integral from here and integral symbol here. And because this is area, entire area, this should be considered as a integral over this area, or you can say integral across the area of PDA. And integral of df, this part equals to f. But I'm not going to go to more details of finding the solution using integral method. The way that I used to use it, and always I ask in the exam from my students, Jeren definitely remember it, that solve the problem using integral method, not using f equals p times area. But in this course, I will accept you to use this simplified formula to find the solution. This form for horizontal, this form for vertical and oriented. The matter is to find correctly area and correctly the centroid. And in some cases, you should know the location of centroid for some surfaces. For example, from the beginning, we used rectangle gates, rectangle plane, and we said that the centroid, here is centroid, yes, here is centroid. And depth of the centroid is, for example, half of the depth from the top or bottom. For the triangle, I already mentioned, here is centroid. Actually, it should be just here is your centroid, and the depth is 2/3 from the top or 1/3 of height of the triangle from the bottom. For circle, we know the centroid exactly is the center. And for half circle or semicircle, this is the line of centroid. Here is the centroid, and this value you should know is 4/3 of r over pr is the radius of the circle. As you always know the area of different regular shapes, to solve some problems in fluid mechanics, you should be aware of these values that shows the centroid of the shape. Okay, so to find centroid, you can use these figures, or you can use your static knowledge to find centroid for irregular shapes. Okay, now the last, at last, I want to ask you a question. Okay, let's join together. Scribe. Okay, the question is, The question is, so far I found force at different planes. But where is the location of these points? Where this force acts on it? For example, let's see our our first example. You see, I showed that resultant force acted here. Where is it?
Middle of site.
What?
Am I right? Middle of site, I think.
Middle of bottom. For example, yeah. Here, look, your answer is correct for this shape. Is okay. Exactly. When I found force, it acts on the centroid of middle. You said middle, but in geometrical we can say centroid.
I'm sorry.
Yeah, centroid of the plane where it is horizontal. How about this? How about these are? How about this? Where is the location of this F? I found if equals to PC times area. Where is the location? Acts here, 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 here. Centroid, where is it? Look, we found resultant force on this dam and the value equals to PC times area. Where is really, if you want to replace this force with this distribution of pressure, where I should put it?
I think it should be again middle, but I think it's not true.
Who's talking? Who is talking?
Burak hocam.
Yeah. Okay, continue.
Should be middle, but I think it's not true. But
yeah.
I think we always think
middle.
You
are, Burak, you are saying should be, but you are not incorrect. Therefore, should not be. Should not be middle. This is correct answer. It is not the middle. Any other idea? Burak discussed with himself, but with hearable voice. It should be, not should be, and the result is it should not be middle. You are right. In the vertical, it's. Do you think it should be centroid? Because we found pressure at centroid. No idea. You are right. You can. You are allowed to say nothing because actually it is not either neither middle nor centroid. The location of the value of this F can be found with the location of centroid, but it acts on the pressure center. Pressure center is always somewhere below the centroid, as you see in this figure. This is pressure center. This is centroid. You find pressure here, then multiply it to area to find resultant force. But resultant force acts on centroid, not centroid, acts on some places below than centroid. How much below the centroid it is shown here. It depends on the moment of inertia of the shape. It depends on the area. But what is the fact? The fact is center of pressure, from now we say center of pressure is always below the gravity center or centroid, and this is the topic for our next lecture. I will talk about the how we can find the place of the force or place of the resultant force acting on submerged planes. Okay, that's all for today. If you have any question, please go ahead.
No, hocam, thanks. And sorry for my late, hocam.
No problem. doesn't matter. Okay. No question? Okay, thank you for being in the lecture. So see you
Thank you
next
hocam.
week.
See you.
Thank you.
Yeah.
See you.